Hello again everybody, it's Scott here. Today I'm going to talk to you about suspension data logging for your track bike. It's something I've been pondering for a while. You can buy suspension potentiometers, linear potentiometers. They're very expensive, they're in the order of $300 odd each. They look a bit like a bicycle pump. They're a cylinder with a shaft in it that you connect up to the motorcycle suspension, and the shaft goes in and out as the suspension moves. The $300 odd, that's $600, was a lot more than I wanted to spend for something that you really only use on a temporary basis. You would generally do your suspension logging, data collection after you've made some changes. Perhaps you've changed springs or made some other changes to the bike, and you need to know how much travel you're using, how much travel under brakes, how much travel you're using in the middle of the corner, whether you're bottoming out, all that sort of information. So you collect that data. Once you've got that data and you've got your machine set up, you generally take off the data logging because you don't need it anymore. So you go and spend $600 on these expensive suspension potentiometers, and they'll spend most of the time sitting in your garage. So that was bothering me. I wanted to collect data, but I don't want to spend that sort of money. So I've been thinking for a while, how can I come up with something that's cheap and that I could make myself? And I did. I have come up with an idea. I made a prototype. I tried it out at the last track day that I did, and it worked perfectly. I collected some really good data. The whole thing cost me a few dollars, plus a couple of hours of my time. Now, I do have a mini lathe, so I had to do a little bit of work on that. So what I ended up doing was I used just a linear potentiometer that you can buy at any electronic shop for a couple of dollars, and I set it up as a voltage divider because the 5 data inputs on most of these GPS-based data collectors, and I have a GPX Pro. Most of the inputs are a voltage, a variable voltage. They're looking for a variable voltage input, and then you just calibrate the collector as to what that voltage is. So the important thing is you must use a linear potentiometer, so that when you set it up as a voltage divider, and I'll talk about that a bit later, when you set it up as a voltage divider, you get a variable voltage as the suspension moves, and therefore voltage equals distance, and you can set it all up to convert the variable voltage into a millimetre reading. So I did come up with an idea. It worked really well, and I'll show you what I did, and hopefully you might be able to make something for your own track bike. So I hope you enjoy the video. Thanks.
I just wanted to explain to you how a voltage divider works. Very common thing to do in any sort of electronics. So if you have 2 resistors connected together, and one end is connected to a positive voltage, so on the positive side of a battery, power source, and then the other end is connected to the ground or the negative terminal. If you were to make a tap in the middle there, tap off the voltage between those 2 resistors, and R1 is always the one on the positive side, so that's sort of voltage coming in, and R2 is the one on the negative side. Then the formula for the voltage that you get at the middle there at that junction, V out is just equal to R1 divided by R1 plus R2 times V in. So I'll just show you how that works. I've got a battery set up here with a couple of resistors on it.
So this battery here, if I measure the voltage across that, that's 13.1 volts. So let's write that down. So that's 13.1 volts. Now, just here I've connected them. I've made a voltage divider, so I've got two resistors here. So that's R1 because it's connected to the positive side. That's R2 because it's connected to the negative side. So if I measure the voltage in the middle there, we should get half because these two resistors are both the same. They're 430 ohms. So the formula, V out, so the voltage at this point, is equal to R1 divided by R1 and R2. So that'd be 430 divided by 860, which is a half. So a half times V in, which is 13.1. I should get a measurement of 6 and a bit volts. So let's see what we get. So I'll put that there and I'll put that in the middle. And I get 6.55 volts, which, so hopefully you can see that, so I'm not lying. So if I measure it in the middle, I get 6.55 volts, which is half of 13.1. So that's how you make a voltage divider. So depending on what these resistors are, you can vary the resistors to get a particular voltage that you want. So hopefully that all makes sense. So I'll just show you, there's the formula again. You can memorise that. And I'm going to test you on it later. Okay, so now I'm going to take this one step further. This is a potentiometer that you can buy for about $2. Now a potentiometer is a variable resistor. So how these things are made is inside there, going from that terminal to that terminal, going around there, is a coiled wire with a fixed resistance per millimetre. And then on that wire, controlled by this knob in the middle, is a wiper, so you're tapping that wire at various points along it when you turn the shaft. So what we can do here is make a variable voltage divider, because as you tap the wire at different sections, you've got different values of R1 and R2. So this is a 10K, that's 10,000 ohm resistor. So if you measure from this terminal to that terminal, you'll have 10,000 ohms approximately. So we can make a variable voltage, because this is V out, that's V in, that's the ground, and that's V out. So we can make a variable voltage, and in this case this is called a linear potentiometer, which means that the wire that's inside there is a fixed resistance per millimetre. So it's a direct proportion. So if you turn the shaft a quarter of the way, you'll get a quarter of the voltage. If you turn it half, you'll get half the voltage, three quarters the voltage, and so on. So I'll show you how that works. So I've connected it up to the battery. So at the moment I've got 0 because the shaft is fully anti-clockwise. So as I turn it, you can see the voltage reading in the background there, and it's changing. I'm slowly turning it. So I'm about, see that's about halfway, and
that's about half the voltage of the battery. So there's the full voltage there, 13.1. So you can make a variable voltage divider using a linear potentiometer. So that's where I got thinking, and I thought, well, how can I use one of these to make a suspension data logger to give me a variable voltage as the suspension moves. So I came up with an idea, and it works. So I'll show you that. Here you can see how I've set up the string potentiometer, homemade. So the smaller diameter wheel has the return line on it, connected to a spring, and that spring goes up and connects onto the triple clamp up top there. And then the larger wheel there, the wire on that goes down and connects to the front mudguard mount. The wire I've used is 8 kilogram picture hanging wire, which is quite good and certainly strong enough for this application. So here's a front view. Very simple to make. You do need access to a lathe, but it's made in two parts, a small wheel and a larger wheel. So with this small wheel, you just need to cut a little slot on the end to make the groove for the wire to run in. And then the larger wheel was cut out of 4mm plate, and then using the lathe put a groove in it to contain the wire. You need to have that outside wheel 60mm in diameter, and that will cover just about any motorcycle or any sports motorcycle. Sports motorcycles generally have suspension travel in the order of 120 to 130mm, both front and rear. So a 60mm diameter will suit most machines. And at the moment this suspension is fully extended, the front suspension, and if you see here I've still got a little bit of movement left, which is what you want. That's the end there. At fully extended, you don't want this to be at the end of its range, otherwise you'll just damage the potentiometer. So that's the front one. This gives you an idea of how it works as the fork tube goes up and down. So you can see there how the spring is pulling it back. Okay, here we have cable B from the GPX Pro. These two wires here, the brown and the yellow, are not being used at the moment. The red wire coming out here of cable B is the 3 volt power supply that it gives you to power up any sensors. So that red wire there is going to both of these potentiometers that I've set up onto one side to give the power supply to create the voltage divider. The green wire there is coming back from the centre of the potentiometer. That's off the front one. It's coming from that, so that's the variable voltage as the wheel moves around. So that's the variable voltage coming back into cable B and going to the GPX Pro. And the blue wire is the variable voltage coming back from the rear potentiometer. So it's coming from the centre pin of the potentiometer on the rear. So I hope that all makes sense. So you can see the green wire, that's going down here, down to the front. There
you can just see it up there coming down, and it goes in behind and connects here to the middle of the potentiometer. They're very simple to set up. And just remember, this outside wheel needs to be about 60 millimeters, and the inside slot that I've made on the inside wheel needs to be roughly half, about 30 millimeters diameter. These are two separate pieces, so all we've done is just tapped a hole there with a 5 millimeter thread and just screwed one bit to the other. And the shaft diameter of these linear, or of any of these potentiometers, they're a standard about a 6.3 millimeters. So you can just find a drill bit that's just slightly larger than that. The potentiometer has a flat section on it, and you can see here on the other side, just there, drilled a hole through there and tapped a 5 millimeter thread so that screw there locks it into place, because that comes through and is locked against the flat of the shaft. So I think you've got enough information there to be able to make these up yourself. So 60 millimeter diameter, about 30 millimeter diameter. You need to machine a little slot on one end to create the groove, and you just drill a 1.5 millimeter hole from the centre through to the edge to be able to connect your cables, which is 8 kilogram picture hanging wire. It's very flexible, certainly very strong, and it's the same for the inside wheel. There's a hole drilled about there for the cable to go, for the wire to go through. So hopefully that gives you some good ideas to make your own suspension potentiometers for a couple of dollars of parts and a few hours work. And here's the one that's been set up for the rear suspension. It's an identical wheel that I made, 60 millimeters diameter, and there you can see the $2 potentiometer, and it's set up as a voltage divider. So the red wire is the feed wire that the GPX Pro provides in cable B, and it provides a convenient 3-volt source to power up any sensors. So the red wire you connect to one side of the potentiometer, then on the other side that goes to earth. So you can see the ground wire there, where I've just drilled and tapped a hole in the bracket and put a 5 millimeter Allen key in to connect the ground wire. And then the middle wire is the tap off point, so that's forming an adjustable voltage divider. So as the wheel moves and the wiper is travelling along the resistance wire inside the potentiometer, it's giving an adjustable voltage depending on where the wheel position is. The same 8 kilogram picture wire, and that goes down, and you want it to be as close to the centre of the axle as possible. So that goes down to a clip that's in a hole drilled through the rear caliper pad mounting pin bolt. And I've got a quick release safety pin connector there, and you can see that's pretty well above the centre of the axle. I've tested these, they work really well. Far better than paying $300 odd for a linear potentiometer when you can make your own using some aluminium plate, a hole saw, a $2 potentiometer from one of the electronics stores, and a spring and some picture wire. So I'm very pleased I've got a video of this working on the track, so you'll be able to see that later. So here's just another view. You have to have a play around and make a lot of measurements to work out where your brackets are going to go. But once you've got it all set up, that seems to be quite reliable. So just another view for you there. Here you can see the readout from the GPX Pro. Top one is the front suspension. So the total travel on the front suspension is 128 millimeters. So it's currently sitting at 126.9 millimeters left. That's because the top out spring is just pulling the wheel back up a little bit, and the rear has 130 millimeters travel. So at the moment it's on the rear stand, which is has the stand points on the swing arm well forward of the axle. So I've got a pretty stiff spring in here, so you can see it's only sagging a little bit over a millimetre. So that's the readout you get on your GPX Pro from the string potentiometers that I've set up. Makes it an absolute snap to set your sag, and you can actually see what your sag is on the run on the track, which is quite interesting. And because you're collecting all this data, makes setting up your suspension a lot easier. You can see how much compression the suspension is getting under brakes and in corners. So I'm quite pleased how this all works. So the GPX Pro has 5 data inputs, and basically it's generally looking for a voltage feed, a variable voltage feed. So the important thing is, if you want to make your own suspension potentiometers, you must have a linear potentiometer, which means that if you set it up as the voltage divider, so you're 3 volts on one side, the other side going to ground, and then the middle is the tap-off point. If you plotted, fractions of a turn of the potentiometer against voltage, you'd get a straight line. So if you turn it, say, a quarter of a turn, measure the voltage, plot that on the graph, then turn it to half a turn, measure the voltage, plot that, turn it to 3/4 of a turn, and then a full turn, plot that on a graph, you'd get a straight line. So therefore voltage equals distance. So the setup or the calibration of it is quite easy. You basically just give it the voltage at full compression and the voltage at full extension, tell it what the travel is, and then the GPX Pro calculates how many volts per millimetre in movement. So if I push down on the back of the bike here, you should see that move. Yeah, and if I pull up, there I've got it at full extension there on the rear. If I push down, so I've pushed it down about 5 millimetres.